Thank you, Brian. Fred did a good presentation before, and I hope everyone is a bit more familiar with. For those that don't know the history of the project, it's practically a European project that started in research, and that could be the source of a couple of crazy design decisions. I'm not going to insist on this history. You'll find it on the web. The idea is it started like in autumn of 2001, and actually we have a very large set of features. My talk here is going to be actually looking at how you can even increase the capacity of Kamailio or the VoIP platform with a couple of internals or different concepts for scalability. Probably you saw this with Fred, but what I want to underline here, it's not an out-of-the-box product, but it's actually a toolkit. So you'll have to build the routing application by yourself. It's not something that you just take it, deploy it, and you are ready to go. Of course, we have templates. We actually deliver a rather complete default configuration file that should be good to start with, all this NAT traversal, location, authentication, IP authorization is there. And also very important to keep in mind is not designed as a typical telephony engine. For Kamailio, or actually for SIP telephony, it happens to be a use case, maybe the most common use case out there. Otherwise, we are a SIP signaling routing. From the day one, the design was targeting scalability to be reliable, a lot of focus on security, as you could see. So before going to the real content related to the topics I want to present, a short list of the features. Again, all these transport layers, we could do bridging IPv4, IPv6, and could be like UDP IPv4 to TLS IPv6. That's kind of transparent. So if a phone is registered with that one and another phone on a different transport layer is just working. We have quite a lot of extension for the big guys out there, so-called IMS extensions. So 4G mobile operators, APIs, embedded interpreters. So if you don't really like our configuration file language, you will probably find something that suits you. A couple of people were mentioning Perl before, but we have Lua. There are other people even adding a Java. I'm not sure how much that will suit performances, but in some cases, when you build an application server, that could save you some time and money. And of course, typical use cases, load balancing, least code routing, number portability are there and for a long time, and sometimes a couple of options, so people get confused. And even you can build new one with existing toolkits such as hashtable or M3 modules, which give options to store, match, and forward from the configuration file. So I'm going to approach actually 3 topics. I will have some examples for the Kamailio configuration file. I'm not going to go one by one. It's just to see eventually how it's possible, and actually it's possible, how it's possible with Kamailio. The slides will be available. I think the recording will be as well available, so you can try it yourself. So no matter would be like, an attacker, a DDoS or whatsoever, it could be actually good traffic, and can happen that you'll have to, face a lot of SIP signaling that you will have to handle with. So you can either detect it's happening, and SIP has the mechanism of, returning, graceful saying, retry after, or things like that. Or you'll have to increase the performance of a Kamailio instance. Or the third option would be scale the entire RTC platform. So we'll look, because depending on your typical or your specific deployment, one of these solutions could be more suitable than the other. So it's not like you'll have to use all of them. You'll just have to select which one is the best for you. So detecting this huge volume of SIP signaling and how you can deal with. Couple of common cases that you can have with SIP. One would be registration. SIP register tunings, that would be the signaling diagram for what's done during a registration. So if you are like a big provider, I don't know, it was some downtime for the network infrastructure, then you'll get all the phones registering at the same time. So you'll get like a tsunami coming to you when the network layer is back. So what's important to do in this situation, detect that, eventually reply and say retry after, and then you randomize that. You say to some phones retry after 10 seconds, some other phones retry after 1 minute. So we have this feature in Kamailio, and you can either use it from like register module, or you can code it in the, how we call it, configuration language script. And of course, it's also important to randomize the expire, because if everyone is like registering for, I don't know, 10 minutes, then again, in 10 minutes, you'll get another tsunami. So it's good to say, okay, your expire is valid for 5 minutes, 7 minutes, or depending on the range. So again, this would be an example of how you can do it with Kamailio configuration file. Then going to the next, which will be authentication. That again could take you a lot of processing, and typically the user profile is in some backend, like a database. So the optimization that you can easily do with Kamailio is kind of caching the user profile. Could be password, but could be also other attributes. And I have this nice hash table module, which is just a generic caching container, let's put it like that, in Kamailio memory. And you can define like auto expire, so whatever you put in the hash table, in this case we'll put the password, then will be automatically deleted. So after 5 minutes, in this case, the last line, practically what you stored there will be deleted. So here would be the scripting that you'll have to add to your configuration file. Look first in the memory. Do you have a password for that user? If not, do the typical authentication, and we have these so-called load credentials that will fetch the password in an AVP, and we store it in this hash table. So next time, you'll get a hit in the cache. And actually, this is quite important to cache it for a short period of time, especially for mobile networks, because typically it's like you send a push notification, and then immediately will be like a registration followed by subscription for messages, and eventually even sometimes, if it's not a push but a wake up by the user, will be also an invite. So it's like in less than 1 minute, the phone will send a couple of requests. So even if you cache it for half a minute, you spare a lot of database interaction or backend interaction. Kind of customized, and it's rather new module. It's useful if you have your own secure infrastructure, but you still need to assert the identity of some nodes. SIP, the standard authentication in SIP, it's a www digest, which is actually not that strong. There are alternatives to avoid this round trip. For authentication, practically the message is coming without any kind of password. The server will challenge back with 401, 407, will follow with another invite, the phone, having this authorization, proxy authorization. So the best would be use client certificates. Of course, it has some drawbacks. But then you have full privacy, full encryption. So this is the best you should actually do, or better said, you must do it in some cases, especially mobile networks. And then we have this tiny module that is kind of, a lot of web services. They give you this kind of API keys that they're hashing over some headers. So you can do this with Kamailio. Again, if you have your VPN network, everything is private. You want to add a node, and you want to be sure that it's supposed to be in this platform when sending traffic. You can use this hashing over a couple of headers or attributes, and then sending over. Of course, it's still a shared secret, not that secure as with TLS, but could give you some scalability in avoiding this round trip for a challenge. That would be the last I would recommend. So I would recommend first client certificates, of a bit of drawback that you have to manage them, but otherwise you have full security and privacy along with server certificate as well. Forwarding, it's another common use case. So when you detect a lot of traffic, what you can do that. So actually Fred presented about pipe limit as well. It's up to you to define this kind of pipe. You count all the calls, or you call calls only from a user or calls from an IP address. And then when you exceed some limit, again, you can send either like a redirect, and you send it to another server, or you can send it to an Asterisk server or whatsoever. So you kind of offload proxying Kamailio to Kamailio, or you send this retry after. Again, some phones, some application can handle that gracefully. The next would be, how you can increase the performances of a Kamailio instance. I mean, if you come from Asterisk, maybe the default options that we have in Kamailio are good enough. So you will have a lot of, capacity to handle with a single instance. But sometime, again, could be an attack, and it's good to know all this kind of optimization. So what to look into a Kamailio instance for scalability, it's about what parameters you can tune in order to increase the capacity of processing for a single Kamailio instance. One would be timer processes. We know that, UDP is not reliable, and you have to do retransmission over UDP. But besides that, there are different modules that will have to do timer-based operation. Like you have a lot of phones behind the net. The server needs to send keep alives every half a minute. You are Zipgate, 500,000, or even 1&1 Germany, couple of millions active phones at the same time. So that's a lot of signaling for keep alives. And you want to dedicate a couple of processes for this type of actions. So look at the modules, and you should be able to identify this kind of either timer process kind of name. So here is timer procs, or this not ping processes. So should be something with either process as a module parameter or timer. Also dialogues, if you want to send keep alives to detect when one side or the other it's dead within the dialogue, would be time consuming as well. So it's good to have dedicated timer processes, and depending on how much work you expect, could be a decision on how many of them you have. Internal hash sizes, if you don't know what hash table sizes, so if you don't know what's a hash table, I do recommend Wikipedia. It has a really nice article about that. It's used for indexes, and it's used by databases systems as well, so it's not something that we invented. And it's practically a list of lists. As you have more lists, then it's faster to search. Now the algorithm, you can't really set it to decide which slot it's done because we do it in the C code, and there are actually entire theories of which algorithm for hashing is better for numbers or for alphanumeric or limited number of characters. So we choose some of them which prove to give a fair distribution. So we do use a lot of hash tables internally besides the hash table module, which you can define it and you can store whatever you want, but then transactions are in a hash table, active calls are kept in a hash table in memory, location records are kept in a memory. So if you have like 1 million phones going to the same Kamailio instance, you better increase the hash table for user lock module. If you are in the range of, I don't know, 10,000 or that one, you probably have enough speed. So this would be another parameter to look for. Look at the modules you are using in the config file, look at the README, see if there is a hash size parameter that you can increase, or sometimes even decreasing could be an optimization because it will use less memory. Next one would be asynchronous processing. So if you get a bit more familiar with Kamailio architecture, you'll see that you will have a pool of processes for handling SIP traffic. So we call them like SIP workers. And you don't really want to do like time-expensive operation in those processes. For that, it would be better to use the asynchronous framework that we have. So think about inserting, I don't know, some statistics in the database. You can easily delegate it to another process other than a SIP routing process. And that could take a bit longer because, the SIP worker processes are just fine routing SIP traffic. And if you think from the point of view of telephony, a lot of work is done by the proxy for the invite. List cost routing, what's the best route, or load balancing, which one is least loaded. And then it's still a lot of other, like reinvites or a buy that you don't want to delay. So it's good to offload whatever you think it's going to take some time to execute via this asynchronous. We have a module, async module, and then we have a group of modules that you can combine, like suspending the invite. Then you use an internal message queue to send it to another process, and then you can consume it, and that process could be started by our timer. Some of the modules for writing to the database, they have asynchronous database query embedded, so it's a bit easier to use from the configuration file, not combining all those three modules or using async module. For the APIs, if you have external APIs, we have JSON RPC, which does kind of suspend, send out. Meanwhile, the SIP worker process can do anything. We get a response back. We resume the invite, and then we send out. Couple of bonuses. Children would be the parameter that would set the number of worker processes. So maybe you want to increase that if you have a lot of traffic. If you do a lot of TCP/TLS, we have some limits on maximum number of connections. So you have a bit of a protection, not having an attack opening a lot of connections. Then, of course, there are some other options, how long to keep it open, and sending like keep alives over these TCP connections. And from the operating system, again, you'll have to increase the file description limits. We have also internal DNS caching, which you can do also with external applications. And then other components in the entire platform, like databases, syslog. If you do a lot of logging, be sure it's in asynchronous mode. DNS infrastructure availability, again, practically, as it is said, when DNS is not working, internet is down. So be sure you have a good responsiveness as well as with your API services. And the last one would be Okay, so we can't go more with an instance. Now it's time to scale the RTC platform. Of course, the first is adding a load balancer. It was covered even last year, and will be a lot of tutorials. I'm not insisting on this one at all. Classic use case for Kamailio. Another one will be externalized services. Although we can do a lot sometimes, there are some resources that you need to share, and putting on all nodes will create maybe complexity to manage and synchronize, and maybe you need to change them quite, let's say, often. So an example would be number portability. I don't know, in US would be that 200 million numbers database, caching that on each Kamailio and updating every hour or whatever you get the updates will be a lot of pressure on each node. So practically, you can have like a central node just focusing on this number portability. You have the routing nodes when you decide that, oh, this is a need to check if it's a number ported or not. You can send this to this central node. And again, you can combine asynchronous processing, so you don't really need to block while waiting for this to be done. Here it's practically, if you think about SIP and what's the outcome, we got an invite in, and at the end, we do either a serial forking or a parallel forking, or we have to send a reply. And here it's this kind of basic routing outcome for SIP. So again, being a framework, it's up to you to blend a couple of these tools we provide and choose what's the easiest way to implement this externalized service and combine it together with the routing nodes. As an example, actually, I haven't put it in the notes, but you'll find link in this slide, and it's a complete tutorial with the complete config files. So combining these three modules, Event API with a JSON, which is a JSON parser, and this RT-JSON, which is routing based on a special JSON document structure. And the external application, I choose to Node.js in this case because it seems to be something quite popular these days, although I'm not into the web programming, although this is server-side programming. So another one would be platform scalability by not sharing the information. You can't really replicate all the information in one node because then practically the entire platform has the capacity of a single node. So think about, okay, I'm at the limit of how many users I want to store in a node, like location, how I could do the routing. Someone is calling via this node, is not finding the target. What can I do now? Parallel forking to the other nodes in the platform. And we can easily do that from config file. There is no need for whatever development. And one node might send not found. The other one will send trying ringing because it's routing to the phone. This may not scale if you have a lot of nodes because doing 100 parallel forks branches will not be good. So what you can do, try to build a super node. And that's where you don't really replicate the entire information. You just replicate minimum necessary to say this guy is with this node. And then that central node may or may stay in signaling based on record routing, which is SIP specific. Again, example, no need to write. It's everything available. It's just configuration file. Scaling more actually can combine the two. So practically you have super nodes for regions, and then in between regions you can do parallel serial forking to get a bit bigger than it was with the previous architecture. So actually, this is the last, I wanted to make like a diagram. We do have some examples on our Kamailio.org website. We have mailing list. I think we are one of the friendliest out there. If you want to read more, there is actually a book by myself and another developer. And to end, next year we're actually celebrating 15 years of development. We have our conference in Berlin, Germany. So if it happens to be around, we kind of plan a special edition, given that we are now quite old. 15 years is like a lot of time. I'm feeling a bit old looking back. So this is it. Questions before we start with the panel. I said it before, we have a booth in the exhibition hall in the open source corner, how it's called there. Feel free to approach us during these days. Questions?
Any questions, guys? We don't have much time. Any?
Here one? You wanted one? Okay.
All right. We'd like to give Daniel a thanks, everybody.